Kia ora. Let's have fun with this virtual titration. So we go and we call for assistance, and then we choose a strong acid, and we're going to use 0.1 mol per litre. That's what that M stands for. And we will use 10 milliliters of solution. The titrant, which is what goes in the burette, will also have a concentration of 0.1 mol per litre, and that will be the strong base. The equipment option will use a pH meter and an indicator, but for the indicator, we'll choose methyl orange. And because we want to go past the end point or equivalence point, then we'll use 25 milliliters. So let's begin the titration. So we're going to have 10 milliliters of HCl in our conical flask or beaker, and we're going to have sodium hydroxide of the same concentration in the burette. So let's get started. So this is what it looks like. We open the lab book and we can see our data points here. Notice before we've added any base, our pH is 1 because the pH of a 0.1 mol per litre strong acid will have a pH of 1. So we can start adding, and we'll add 1 milliliter at a time. So notice how the pH has gone up, and we can add this. Now you can also see this on a titration curve. So there are those additions we've done. So you can see how it's a fairly gentle curve, and we'll go to 9 milliliters and turn the page. And now we'll add smaller volumes because you can see it's starting to go up. So we're adding 0.2 at a time. Notice the color change. It's becoming a bit more yellow, and there at a pH of 7, it has become yellow. So if we continue adding, you can see we're now going to have a gentle slope again. So I'm going to just add a little bit more. And you can see we're getting that gentle slope again. So that is the shape of a strong acid, strong base graph. So we can go back and do the same thing, but start with a strong base. So if I go to menu, main menu, call for assistance again, and for the analyte option, I'll choose strong base, and I'll keep it at the same concentration. Use 10 mils. Titrant in the burette will be the same concentration. It'll just be an acid. This time round, I'm going to use phenolphthalein, and I'm going to still use 25 milliliters. Begin my titration. So now it's the same titration, except I've changed my indicator, and I'm using base in my conical flask. So let's open the lab book. Notice that in a basic solution, phenolphthalein is pink, and my pH is 13 for a 0.1 mol per litre strong base. So if I now add, okay, you can see that the pH is dropping, and if I look at my titration curve, you can see it's a gentle drop. So I'll keep on adding until I get to about 9 milliliters. Okay, I'll turn the page, and now I'm going to add smaller volumes. Now, it's still staying pink, but have a look now at what happens. You can see the color has suddenly changed. The color change is called the end point, but it also happens to be the equivalence point when all the bases neutralize the acid. So I will now carry on, and you can see we've dropped from that cliff, and now we're having a gentle slope again. So I'll just speed it up so you can see that slope. So let's try one more where we change our concentration. So we're going to use strong acid again, but let's use now 0.5, and we'll still use 10 mils. For the burette option, we'll have a 0.5 of strong base. That's 0.5 moles per litre. Equipment, we're going to use a 25 mils. We'll use litmus, although that's a very poor indicator. And let's get started. We'll again add 1 milliliter at a time. But before we do that, notice we're not starting at a pH of a 1 anymore because our concentration of the acid is higher, so our pH has dropped. So just be aware of that. But if we do this and we go, I'll just show it's the same sort of gentle slope, but starting at a lower pH, and we'll get to 9, turn the page, and now I will add small amounts. And if you look at the color, it's still red for an acid, but now it's suddenly turned blue at a pH of 7. it's the same equivalence point, even though we've changed our concentration. So we'll now just add a bit more and speed up and so on. So have fun exploring this, try different concentrations, have the acid one concentration, the base another concentration, see what happens at the volume as well as the pH. Kia ora.